This is our video submission for the final project for CSCE 678. This video is a comparative analysis of the virtual machine solutions offered by the three largest cloud providers, Amazon Web Services, Microsoft Azure, and Google Cloud Platform. My name is Marlon Gonzalez. I am joined by Luis Martinez Morales and Nikki. A virtual machine is a fully isolated guest operating system running on virtualized hardware. This means virtual CPUs, virtual RAM, virtual disks, and NICs provided by a hypervisor layer. By abstracting physical resources, VMs can deliver isolation, hardware faults and software crashes stay confined to each guest, elasticity, virtual CPUs, memory, and storage can be provisioned or reclaimed on demand, and portability. You can snapshot, migrate, or clone a complete VM image across hosts or clouds. VMs are commonly used in scalable web services, development and test sandboxes, legacy app support, and CPU-intensive batch jobs. We will compare cloud VMs on 4 axes. Functionality: how intuitive and configurable is the VM interface, and what feature differences exist across providers? Pricing: what billing model do they use? Is there a free tier or trial, and are there barriers to entry? Performance: how do VMs stack up in benchmark tests? Compute, storage, and network. Security: are there startup misconfigurations that pose risk, and how well is each VM protected against attacks and vulnerabilities?
AWS is the largest public cloud provider, and its core VM service is called EC2, or Elastic Compute Cloud. EC2 offers on-demand, scalable virtual machines with a wide range of instance types, including general-purpose, compute-optimized, storage-optimized, and GPU-based. It is highly customizable, letting users choose OS, hardware, and storage. And with features like autoscaling and load balancing, EC2 makes it easy to handle varying workloads efficiently. Setting up a VM in AWS starts with choosing a region and availability zone, then selecting your instance type, like a T2 Micro or M1i Flex Large. Next, you pick an Amazon machine image, such as Ubuntu or Amazon Linux, and configure your storage volume, network settings like VPC and subnet, and security groups. Finally, you create or use a key pair for SSH access. AWS offers a web console, CLI, and Cloud Shell for managing EC2 instances. You can start, stop, reboot, or modify VMs and access them via SSH or Instance Connect. All access and permissions are controlled through IAM roles and policies. AWS offers a 99.99 SLA for EC2 instances, but only when they're backed up by EBS storage and deployed across multiple availability zones. Just like Azure and GCP, high availability requires a multi-zone setup. However, a key difference with AWS is how seamless it is to set up, thanks to the default support for cross-AZ networking and load balancing. You don't have to architect as much from scratch. If the SLA isn't met, AWS provides service credits, 10% for uptime below 99.99%, 25% for below 99%, and 100% credit if uptime drops below 95%. Compared to Azure, which has no SLA for single VMs, and GCP, which separates SLAs by tier, AWS gives strong guarantees and smoother scaling across zones. Microsoft Azure is the second largest cloud provider, primarily known for its strong open source software and cloud support. Azure VMs offer on-demand and scalable VMs across both Windows and Linux environments. Azure has a series of VMs that are optimized to handle various types of tasks, including the ones that are listed, but there are many more as well. Azure VM has a wide OS image support with custom VHDs and managed disks. Finally, Azure VMs seamlessly integrates with the rest of the Microsoft tech stack and services. The VM creation steps for Azure are pretty straightforward. Simply select the region and availability zone, choose the VM size, afterwards pick the OS image, and finally set up the virtual network and make use of other features such as SSH access. Azure has its own version of the Cloud Shell. This browser-based shell comes pre-installed with the basic tools you might need, such as Git and Python. A local setup is not needed as it runs on a managed container. It is easy to start, stop, and create VMs via the CLI or the user interface that is available online. Azure guarantees 99.99% uptime for virtual machines, but only if you deploy 2 or more VMs across at least 2 availability zones in the same region. This is similar to GCP's premium tier SLA, but unlike GCP, Azure provides no SLA at all for a single VM without redundancy. If you use an availability set, which still offers some fault tolerance, you get a slightly lower 99.95 SLA. The table shows you how your deployment architecture directly affects your uptime guarantees. Definitions like availability set, zone, and region are listed below, but the key point is that Azure's highest SLA depends on cross-zone redundancy, and no SLA applies to standalone VMs. So compared to AWS and GCP, Azure is unique in being more strict. You only get their top-tier uptime if you explicitly architect for high availability.
Google Cloud Platform, or GCP, is the third largest provider, focuses on data analytics, machine learning, and open source software. Compute Engine is GCP's VM service, comparable to EC2 or Azure VM, offering scalable, high-performance compute. Key features include the Instance Series, E-Series for general purpose, N-Series for balanced flexibility, and so on. Custom images and disks, full Linux and Windows support with user-provided images. Free trial, $300 and credits valid up to 90 days for new users. To launch a Compute Engine VM, select your region and zone, pick a machine, choose an OS image, configure your boot disk's size and type, set up networking firewall rules, and SSH access. For CLI users, Cloud Shell gives you a ready-to-go environment with gcloud, Python, Git, and many more packages. It's free and easy to learn and lets you start, stop, create, delete, or modify VMs. Google Cloud's US regions offer 2 tiers, Premium tier with a monthly uptime percentage promise greater than 99.99%, and a Standard tier with a monthly uptime promise greater than 99.9%. If these SLOs aren't met, you earn service credit refunds, which scales up to 100% as the monthly uptime percentage dips to below 95%. The on-demand pricing model offered by AWS, Azure, and GCP is as follows: $0.0416 per hour on AWS, $0.0832 per hour on Azure, and $0.067 per hour on GCP. There is also reserved and committed use. This includes 1 or 3 year commitments yield 30 to 70% discounts off of those on-demand rates. GCP and Azure also offer a free tier and trial, limited time credits such as the $300 on GCP and $200 on Azure, or always free micro virtual machines for basic development and test. Virtual machine evaluation. On this slide, we're looking at a traffic light view on how each cloud provider stacks up across the 4 categories. In terms of functionality, AWS, Azure, and GCP all earn an excellent green. Every provider handled VM creation, snapshotting, deletion, and basic integrations with 100% success. In terms of pricing, AWS stands out as our best value, delivering the lowest hourly and egress costs. Azure and GCP both sit in the yellow moderate band. They're competitive, but come in slightly above AWS's baseline. Regarding performance, all cloud providers provide adequate compute, bandwidth, and disk performance for modern applications and tasks. AWS does deliver with the highest raw compute power, with Azure offering the best disk and network bandwidth. GCP performs moderately in comparison. The default security measures available at VM startup are all good across the board, but Azure does provide the best security configuration, while GCP and AWS require a bit more manual configuration. Key takeaways and trade-offs. All 3 cloud providers offer mature, feature-rich VM solutions. Your choice really comes down to what your application values most. AWS stands out with the deepest feature set and the best cost per hour on its most common instance types, ideal if you need raw compute power backed by the world's largest cloud platform. Azure delivers enterprise-grade software with built-in monitoring and security defaults. Its pricing sits in the middle, and while CPU benchmarks trailed slightly, its internal network bandwidth was consistently the fastest. GCP shines for data-intensive workloads, offering competitive pricing and strong compute performance.